We're talking about objects and the math object today with chapter 12. So objects just are things that are in the real world that can be represented by code. So we'll talk about that concept, and then we'll look at the actual data structure and the syntax for that. Talk about how to access properties that are stored inside an object, how to modify an object, and then we'll go through some object methods, which are just functions that are stored inside of objects. And then this concept of object equality, like how does JavaScript evaluate if one object is equal to another object? We will look at a new type of loop that will iterate through object keys so that you can access the data one property at a time, and talk about, what happens when you have an object that stores other data structures, like another object or an array. And then we will flip that and talk about what happens when you have an array that stores a bunch of objects in a list. Because you're going to need to work with that for a number of things, but especially, you'll need it for Studio today, and then you'll need it for graded assignment number 2 as well. Okay. So this concept of an object, we pretty much just define an object as anything that can be described. You can represent it with code if you can describe it. And so we have, two pieces of fruit here, right? And they have certain properties in common. They both have a diameter, they both have a color, they both have, they're either a citrus fruit or they're not a citrus fruit. So we kind of have these values for those properties, and they're similar in their structure, but they are two different objects, right? So, all right, give me a second. Right, apple and orange. I don't know why those were. Okay, let's move on. So let's talk about it in terms of actual JavaScript with the syntax. Here you have, an object. Each object is represented by curly braces. That's how you define, the area where you're going to actually store the properties and methods. So anything that's stored with key value pairs is a property. And there can also be, each key value pair should be separated by a comma. This is a common mistake when you're first working with this. Some people try to use semicolons. They're not actually separate lines of code. They're sort of kind of a list, but they don't function the same way as arrays. But you do want to separate each pair with a comma. And then you use, set it up with the entire thing. You're usually storing that in some sort of variable, and then you would just follow that with a semicolon, because it's just a single line of code when you're defining the entire object. Okay, so we have our apple and our orange, same information from the previous page, and I just kind of have it in tables here, and you can see there are, names that represent the piece of data that you're storing on the left. And on the right column, we actually have its value. So those are the keys and the values that get stored. So in code, it looks like this. You would have diameter is 2.5, and down here, the diameter is 3. And then color is red as a string, and this one is orange as a string. So notice that's a number, and this is a string. And then, is citrus? Well, that's a Boolean, right? We're asking a question. Is that true or is that false? So we can store those values in there as well. Each key value pair is separated by a comma. The entire thing is inside the curly braces. And then we're assigning them to variables. So now we have an object stored in apple and an object stored in orange. They have the same properties, but different values. Okay, so let's talk a little bit more about these keys and values. The key is essentially anything that can be stored as a string, which it can also be a number. It's just that it doesn't display it with the quotes, but behind the scenes, it's storing it as a string, and that's an important thing to remember that may come up in the future. So the key value pair is considered a regular property if that value is just like a string, a number, a Boolean, another object, an array. But if you actually store a function as the value, then we call that a method. And you've been using methods because you've been using array methods and string methods. Remember how we talked about how strings and arrays are actually objects as far as JavaScript is concerned? And that's because they have all of these built-in methods associated with them where you can call those functions attached to those objects. That's what's going to happen here. We're going to actually enclose, encapsulate some functions with the object that can be called on that object. So here's an example where we have a stove and we have 4 regular properties. Type is gas, finish is stainless steel, number of burners is 4, has hood is true. So we have different values, right? Strings and booleans and a number here. And then we want to add a method. So that would be something like this. We could give it a key name, cook, and then put in something like an anonymous function here where, and I'm gonna outline this more in the future. We'll go over this very closely, but you can see that it's just basically, it's a key value pair. It's just that the value is the definition of a function, right? That's a method. Okay, so just as long as you're clear on the difference between a regular property and a method, it just has to do with whether it's a function or not. Okay, one thing I want to do before we do more slides is just come over and do a quick example of an object here. So I'm going to create a basic object that represents the pirate flag, and we're going to call it Let Jolly Roger equal, and then I'm going to set up my curly braces and follow it with a semicolon. And then in here, indented, I'm going to set each of my properties. So I'm going to say, let's give it a name. Jolly Roger, and we'll give it a color, black, and we'll have a description of the image. So white skull and crossbones. Okay. Something I just will tell you right now, you're out there in the wild and maybe when you're a developer, you're going to see people put commas like that after the last one. That's totally normal. And sometimes a company will prefer that you do it that way. And they'll even have code that will like automatically format that way for you. It's perfectly valid. So if you're wondering whether you can put a comma after the very last one, you absolutely can, just like that. But you don't have to. Okay, so let's just print this object. We just need to see how it comes out now that we've saved it. And we're going to find that it looks pretty much just like it does in the code. But let's run it. Okay, so I'm going to node objects.js. There we go. Okay, so the console here clearly shows each of the keys represented in white and each of these strings represented in green that are the values for each of those keys. Okay, we're going to work a little more with some of these things in a minute, but let's go talk about the difference between arrays and objects just for a minute so you can understand how data is stored inside of them differently. And then we're going to talk about kind of how you would start looking at some of these values. So with arrays, elements are ordered sequentially, right? And you do it by index. You have this 0 indexing idea. But with objects, the order of the properties, the order of those keyed value pairs doesn't matter. It's not going to go look it up in any particular order of how you added the properties. It's just going to look it up by key. You give it a key, it gives you the value, rather than giving it an index to give you the value of the element. So over here, we have a couple of examples. I have an array that just says pillow info, and it has a bunch of values in it, but we don't really know what these, I mean, these all apply to the pillow, but we don't have any more specific information about what they represent. So we just have blue, round, velvet, 18, right? A better representation of your pillow is to use an object where you can actually name these keys that help you understand what those values represent. So we have color, blue, shape, round, fabric, velvet, size, 18. And you can think of these keys just like you do with variables where you want to give them good descriptive names that help you understand what they represent, right? Because that's really essentially what they are. So I can come over here and say, I want to go to pillow info at index 2, and I see what?
That velvet.
Yeah, velvet, right? And if I go to pillow and then give it the key fabric, I'm also going to see velvet, right? So it's you look them up a little bit differently. With pillow info, we had to look it up by index. With the object, we looked it up by key. All right, let's talk a little bit more about this notation. This is one way to do it. There's actually two. You can access values with bracket notation, just like I just showed you. And remember that object keys are stored as strings. This is important because you need to use quotes with bracket notation to do that, okay? On the other hand, you could access values with dot notation. So you use the object key, but you do not put it in quotes. And it's also, there's no parentheses after it if it's just a regular property. If you're just trying to access a string or an array or a number, you don't want to use parentheses after it. The property that you guys are already familiar with using is something like a string dot length or an array dot length, right? Remember how dot length doesn't have parentheses after it? That's because it's a property. It's not a method. So you're going to do that the same way with your object properties. So I have a novel. Title is Peril at End House. Author is Agatha Christie, and the number of pages is 226. So if I look up novel and give it the string author, I should see.
What was that? Agatha Christie.
Right, and novel.title is
Peril at the end of End House.
Yeah, and then if I go back and I look up num pages, I get 226. Yeah. Okay. So you can do it either way. It doesn't matter. You can, but the main thing to remember is that when you do brackets, you have to use quotes when you're referring to a specific key that exists inside that object. If you leave the quotes off, it's going to be kind of like looking for a variable, which we'll get to later. And right now, we're not trying to use any sort of variable. We're looking for a specific key. So because it stores it as a string, we look it up as a string. And that gets us the values we're looking for. And this is how we do it. This is how we access them. So let's do a little bit of this. We'll use this Jolly Roger object that we already have. And first, let's print the name. So I'm going to say Jolly Roger. I need to log it though, don't I? Okay. Let's log Jolly Roger. And I'm going to use bracket notation this time. And I'll just give it name. And we'll run it. And there it is, Jolly Roger. Okay, now let's print the color using dot notation. Dot color. And there it is, black. Okay, now let's print a template literal that describes this flag using all three of its properties. And we're going to mix up bracket notation and dot notation. So I could do something like console.log and say and we'll do the name, Jolly Roger dot name is and then we can use the color, Jolly Roger, and I'll use bracket notation this time. Okay. Flag with the image of and then we will use one last placeholder here and say Jolly Roger, and I'll do bracket notation again and do image. Okay. All right, let's run it. The Jolly Roger is a black flag with the image of a white skull and crossbones. Okay, so you can immediately see how useful it is to store multiple pieces of information about the same thing in an object and then be able to access each of those properties selectively to do something like putting together a sentence that has multiple pieces of information about that same object. We're going to do lots of examples of this, and you'll have lots of opportunities to do this in your studio today as well. So you'll get comfortable with this. But the point is, we accessed the actual values stored by using the keys, and we were able to do it both with dot notation and with bracket notation. Okay. Notice when I'm hovering over Jolly Roger, VS Code's telling me, oh, hey, I recognize that. It's an object, and here's all of the keys and their types. So you can kind of see what to expect. So that's a helpful thing. VS Code likes to be all kinds of helpful. Okay. What if you want to modify a property? You want to change the value. You can do that. You would first, you can set the value of an object's property directly. And you can do this with bracket notation or dot notation. So it's totally mutable, just like an array is. So, yeah, there we go. Okay, so let's say that I wanted to change the title of the book to The Hollow. What would I put here to assign that new value? Do it with dot notation.
Novel.title.
Yeah, novel.title. Good. Okay, and then let's say I need to change the number of pages. Let's do that with bracket notation.
What was
Novel bracket number pages.
Novel brackets num pages.
Yes, and specifically, we want to make sure that it's in quotes, right? That's important. Okay, and then we can do the same thing. Let's say, oh yeah. This is also we can add properties this way, brand new properties. So if I wanted to add a new property called genre, I could do that. I'll do it with dot notation, and I'll just say novel.genre is mystery. It does not have to already exist for you to do this. You can create it this way and just say, hey, I've got something I need to add to this object. Let me just do that, and do it the same way you would if you were reassigning. So again, I can create a new one with format, and maybe I use bracket notation this time. So that would be novel. I use brackets, quote, format, and it sets a key called format and gives it the value paperback. So now if I console log the novel, we're going to see something with how many properties?
5.
5, yeah, because we changed 2 of them, but we also added 2 of them. Good. Okay, so that's how that works. Let's do a couple of examples here. Okay, so we've got an object already existing, let Black Pearl, and we have the name Black Pearl, the captain Jack Sparrow, the crew are a bunch of pirates, right? So Barbossa and his crew mutiny and steal the gold, right? And they get cursed. So we need to change some information because Jack Sparrow is no longer the captain of this ship, and the pirates are no longer alive exactly. So let's do it. Let's say Black Pearl, and we'll change the captain with dot notation. So I'll say Black Pearl dot captain, and then we're going to store a new value, Hector Barbossa. And we want to do the same thing with the crew, but I'll do it this time with bracket notation to illustrate that. So I'll say Black Pearl and then give it the string crew in brackets. And we'll say undead pirates because they are not just regular pirates anymore. All right, now let's go ahead and print this so we can see the new values that have been changed. All right. All right, there we go. The name is the Black Pearl. That hasn't changed. The captain is Hector Barbossa. The crew are undead pirates. All right. Let's look at another object. We've got the interceptor. Its name is interceptor, but we don't have any other information about it in here yet. So let's go ahead and put this in here. So Jack and Will steal the ship from the Royal Navy, right? To sail to Tortuga. And so we need to add the new captain because Jack Sparrow might have lost the Black Pearl temporarily, but he's now, for a moment, the captain of the interceptor. So I can use dot notation, interceptor dot captain. It's a completely new key that did not exist before. And I'll set it to Jack Sparrow. I'll do the same thing with the crew. So I'm going to give it this, the same three properties. Sorry, there we go. Same three properties as the Black Pearl had, with its own unique values, a ragtag group of sailors. Okay, now we'll print it so we can see the final result with these new properties added. Okay. And so we have them, yeah. Interceptor, Jack Sparrow, a ragtag group of sailors for name, captain, and crew. All right. Who has questions at this point about anything I've done so far? Any clarifications?
Yeah, go ahead.
I have a question about object. Is it better to use function itself or can I create a function after the object?
So using, did you hear that?
No.
Okay, so using functions in an object, is it better to code the function into the object itself, or is it better to code the function outside of the object? Is that what your question was?
Yeah, we're about to talk about that next. I'm going to show you both ways.
Yeah.
Do you prefer dot or bracket?
I heard
Catch
that
that
one.
one? Yeah.
Yeah, I always get that question. Yes, I prefer dot notation. In the long run, it's cleaner and easier to read. If all you need to do is access or change something, I find that to be easier. However, when we get to working with certain things like the special loop we're going to learn about in a bit, for iterating through the properties, you'll find that bracket notation is absolutely necessary. There are certain circumstances where you have to use bracket notations, but if I don't have to, I almost always use dot notation. It's just cleaner. Yeah. Any other questions?
Yeah, what's up? Did you have one? I think we're good for now.
Yeah, okay. All right, let's talk about methods. That actually was the very next thing I was going to talk about. So the very first option for adding a function to an object is, what if you have an existing function that's been defined outside the object? You can assign it to a key with a simple reference to the function. So that's important. You're not calling the function and getting its return value. You're just referring to it. So really a way to look at this is it's like you're setting an alias, right? We've already learned how to do that. You can store a function under another name. Even if it already exists, it doesn't have to be anonymous. So you can do that, and then you would call the method using dot notation with that key name, and then pass any of the arguments that might be required, depending on the definition, into those parentheses. And this option generally works fine, as long as that method doesn't depend on knowing the value of any of the other properties in the object. So, for example, we have say hello, and all it does is return this phrase hello there, right? And there's no variables needed for this. There's nothing that changes. It's always going to return that exact string. So it's not depending on the name or the occupation here in Obi-Wan's little object here. So we can just use this as an outside thing, and Obi-Wan will say hello there. And so we can set a key called greet. And then what would I put here to make sure that we're using this function when we use greet?
Say hello.
Just, what was that? Say hello? Yeah, just say hello.
Yeah, say hello, no parentheses, because we're not trying to set the string hello there into greet. We're trying to set a reference, an alias for the function itself, so we can call it, attaching it to Obi-Wan. So now I can say Obi-Wan.greet and put the parentheses on, and what am I going to see?
Hello there.
Yeah, I'm actually calling the function, but I'm calling it using the name of the method that's attached to the object. What if I just console log Obi-Wan.greet with no parentheses?
Function say hello.
Yeah, function say hello, good. So just as you would expect, anytime you use an alias, it's just going to point at that original function. As long as that original function has a name. We're going to see some different behavior when we try to do it with an anonymous function. Okay, so that's option one, is to use an existing one. So let's go look at that. I'm going to do an example for you, and then we'll go look at option two, using an anonymous function. So here I've got a basic function called set sail, and it says weigh anchor, hoist the sails, split quick, you dibbies. And so we're going to add a property to our existing object interceptor, but it's actually going to be a method. So we'll add sail and say interceptor, let me type that correctly, interceptor dot sail. And it needs to just be a reference to set sail, right? Without calling it. Okay, so now let's just print the interceptor so we can actually see the way that it's stored now. Okay. All right, and all we see is that sail represents the function set sail. It's an alias for that. So what about using it? How would we use it? We can call this method on the ship here. So it says call the method on one of the ships. The only one we put it on was interceptor, so we'll do that. And you do have to use dot notation for calling methods. You can't use bracket notation for this. So that is another reason why I tend to default to dot, is because I just use dot for everything if I can. Okay, so we will go ahead and run this. And we see our return, weigh anchor, hoist the sails, split quickie divvies. However, if I were to say interceptor dot set sail, does anybody know what's going to happen? Okay, if you don't.
Is it a reference error?
It's a type error, believe it or not. Yeah, it identifies it as a type error because it says, I don't recognize what that is. You know, I'm looking for set sail as a reference, but it's not a function. Because you're looking for a key, and set sail just doesn't exist in there. The only thing that exists is sail. We can see it right there. Okay. Yeah. So it's kind of interesting, but that's an important point that some folks get confused on in the beginning, is you don't ever call the original function by its name. You have to use the actual name that you set up as part of your as your object, which in this case was sail. Okay, I'm going to comment that out so that we don't continue to get that error. All right, let's talk about the second option. What if you just wanted to create an anonymous function in place and not have a named function separately? And this is very common, but it's actually essential if you're going to refer to other properties within that object and you need to get their specific values. So you would just define it and assign it to a key. And then anytime you need to refer to the other properties or methods from inside that object, you use the this keyword. Okay. So with movie, I have the title is Gosford Park. I have director Robert Altman, and describe is a function. Okay, so inside here, I can, just put whatever code I want to be executed whenever describe is called, right? So I might just put return, and then I create a template literal, and I have two placeholders. The first one is to access the title. And because I'm doing this from inside this definition of this object, I have to use this and say this dot title, and it'll go get the value from title. And I say this dot director, and it'll go get the title from, the director from the object and get that value. And I've got that in parentheses. So if I call movie.describe, I should see
What was that? Yeah, Gosford Park, Robert Altman.
Yeah, Gosford Park by Robert Alwyn. Good. Then if I were to just, say movie dot describe, I mentioned before that because we don't have a named function, it can't like point to that, right? So instead, what it does is it just gives you the name of the key back because that's the only name it has for it. Okay, let's take a look at this. We've got a number of phrases here that are for Cotton's parrot. Different things that he says along the way. And so we're going to create an object for the parrot that's going to give us some information about the parrot. And we'll have a speak function that's going to go and choose one of these phrases. And I'm going to get a little bit ahead in the chapter because I'm going to go ahead and use some, random and rounding and things like that. We'll talk more about it specifically in a bit, but this is more fun to go ahead and use it now. So I am. Okay, so we're going to set a few properties here. We'll say owner is Cotton. And species is a blue and gold macaw. And then we'll have our speak method. So if I want to define this in place, I start to set it with a key like normal, and then I go ahead and just create my function definition just like this. And then inside that, I can do whatever I'd like to do. I can have as many lines of code as I want. So the first line, I'm going to go get a random index. So we'll talk about this in a few minutes, but I'm just going to round down however many the length of phrases is out here. We're going to take that and multiply it times math.random to get a random number. Okay. All right. So the length of this is 6. So it's basically that what this is going to do is provide a whole number because it's rounding down from 0 to 5, which is exactly what we need for indexing for an array, right? Again, I'll talk about it more later. So don't worry about it if you didn't quite understand that right now. Let's just go do it. So then I can use that index and go get a phrase from here and just print it. Okay. So let's go ahead and call this method 3 times. We're gonna see, parrot.speak, and I'll put the parentheses on there to call it. And then I'll do it again. So I can just, there we go. And we'll see how this randomization works. Okay, uh-oh, fire in the hole. And then we got any port in a storm, which he does repeat himself. So I guess that's perfectly appropriate. And if we run it again, we'll get completely different answers, right? Dead men tell no tales, walk the plank, shiver me timbers. So this allowed us to provide a function anonymously that's stored inside the parrot object, doesn't exist anywhere else. And it does exactly what we're asking it to do, which is to go get a random phrase from this array. Okay, yeah, we'll definitely look a little more at this in a bit in terms of the math object. For now, I also wanted to do an example of where we're using the this keyword because you need to definitely understand the difference of if you're trying to access that value that's inside the object, you can only have one way to do it, and that's with this. So we're going to add we're going to add a property to Black Pearl this time. So if you remember, if we, if we kind of come up here and look, Black Pearl right here. Captain is Hector Barbosa, crew is Undead Pirate. So we have 3 properties already. Now we would like to add a method to describe it and to get all of its properties. Okay, we can do that. We can just say Black Pearl dot describe. So we come up with the name of that key for this method and say, here's the function definition. So it's still an anonymous function. I'm adding it after the fact. And all it's meant to do is to print this dot name. Now, again, I might be doing this after the fact, but it's going to be stored inside the object with the describe key, which means I can use this to refer to everything because it's stored inside. Now, you can also do this by just placing it in the object in the first place, but either way, it knows what to do with this keyword, that it means find those values that are stored as part of the same object and then get their values, whether we add it later or we do it now. Okay. Okay, so that is, let me pull this out a little bit. There we go. Okay, keep that all in one line. Let's print the object so we can see that method. So I will print black pearl, and we should see our original 3 properties plus the new method. Let me go ahead and do this now. Okay, there we go. So the name, captain, and crew as described previously, and now it just says describe is a anonymous function, and that's kind of interesting, right? Because when we were trying to, like, if we were to console log, okay, hold on. Whoa. If we were to console log just black pearl dot describe, kind of like we did on the slide without calling it. It also is saying anonymous, it's not actually pointing to describe. Sometimes you'll get inconsistent results, but that's okay. Either way, it's an anonymous function, so it kind of doesn't matter. But if you get something like that, then oops, I forgot to call it. So let's go ahead and actually call it. And actually, we don't need to print it because it already is logging something, right? So I'm just going to say black pearl dot describe and then call it. There we go. The Black Pearl is crewed by undead pirates under Captain Hector Barbosa. So to recap, I added a new key to the existing object Black Pearl. I defined a function, and even though I added it after the fact, I still try to add my semicolon. I still was able to use this keyword to refer to the specific name, crew, and captain of that object because it's being defined inside it. Everything is going to be enclosed in that object, and so it'll know where to go to get to those values because they already exist there. Okay. I want to talk about object equality, how objects are stored in memory. Arrays and functions and objects are all stored by reference in terms of their location in memory. And so you can have 2 objects that have the exact same properties, but they will still be considered unequal if you try to compare them. So you can create an alias that will just point to the original object, and it's not a true copy, right? And so there's going to be, some ways that you can make true copies. You don't have to worry about that too much right now, but I'm going to show you. So we have user 1 is first name Bob, last name Loblaw. And so then we have user 2, and we have the exact same keys and values, right? Identical. If I say user 1 is loosely equal to user 2, even loose equality, what am I going to see?
1 true.
I think my stuff is out of order here. Oh, there was another, yeah, spread operator. I'll talk about that in a second. Okay, yes, it's false. Because again, I declared 2 completely different objects, which means they're stored in 2 different locations in memory. So even if they have the same properties, JavaScript is not looking inside and evaluating it in a deep way. It's evaluating it in a shallow way. It's just looking at location in memory. That's it. So you can say, is this loosely equal to this? It still is just doing a shallow comparison and looking at the location in memory. So false. That's actually false. Let's say you have an alias, and so you say, user 3 is user 1, and all you do is basically point to user 1. Same way you can do with aliases with functions, you can do the same thing with an object. So no problem. We say user 1 is equal to user 3, and that's true because it is user 1. It's just under a new name. So let's say I change user3 last name and give it a new value, the tomato. What am I going to see when I go to user1 last name?
What was that?
Wow.
Bob the tomato?
Yeah, just the last name though will be the tomato, right? Yeah, but but the whole name is Bob the tomato. Yeah. So we might have changed it using user3, but it's an alias. So it's actually storing it as part of user1 because there is no separate user3 object. Okay. The way that you can make this true copy, one way that you can do it is to use a spread operator. We'll talk about this a little bit more when we get to chapter 28. But this is a way you can extract the properties and just say assign them to a new object like this. And then if you do that with user4 and you go to check, you change the first name to SpongeBob, you're going to find that user2, even though you use the inner properties and of user2 to set them inside user4, because you did it this way, it still has the last name as blah 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 blah. So got any Arrested Development fans in here? Okay. So anyway, that's how it works. And I'm trying to remember if I have, no, I don't have any examples of this. This is enough to discuss it. Okay. Do I have any questions at this point? Anything I've covered recently before we move on? We have a little bit more to do before we take a break.
Not looking that way this time.
Okay. All right, let's talk about iteration. There's a new loop, for in is what it's called, the for in loop. And the idea is that you can go through an object and access each of its key value pairs. But because there's no index, you have to just assign a variable to represent the keys. And that's important. They represent the keys, not the values. And then you can just use bracket notation with the object name and the key, or the variable that represents the key, to access the value for that key on any loop. So let's say we have a song. The title is First Fires, artist is Bonobo, album is North Borders. Probably, in my humble opinion, his best album, still is my favorite. So I can loop through this, key value pairs, and I'll just do them one at a time. And so I'll say for let, and I declare not an index like I can give it any name I want, but it represents the key. I could also say it just represents the property. So I'm going to say let property, and that's just going to represent that key in, and then I actually go to the name of the object and say song. So I'm saying for every single property in song, let's loop over it and do whatever code is in this bracket. Okay, so that part still works like a regular loop that you're accustomed to, where anything inside those brackets is the code that's executed as it's looping every single time. So I'll first console log the key. So what would I put here to do that?
What was that? Property?
Yeah. I want to use the generic variable that I created to represent the keys, because they're going to be different every time it goes through the key value pairs, right? So I can't refer to any specific key. That's why I'm using a variable. How about the value? How would I access that?
Any takers?
Nobody?
What was that? Song bracket property you said over there? I'm hearing a song dot property as well.
Okay, yeah, you can't use dot notation because then it's looking for a specific key named property. You have to use bracket notation, and then you'll notice there's no quotes. So this goes back to what I was saying before about if you use quotes, it's looking for a specific property with that name. If I said a song, and then put title in quotes or artist in quotes or album in quotes, it would, every single time it loops, it would just go get that same value that belongs to that specific key. But if I want to represent the key being anything, any of these as it's looping through, and it's going to do it in whatever order it feels like because they're not indexed in any sort of particular sequence. I have to use the variable property that represents a key, and I need to not use quotes because it has to be variable so that every single time it refers to a different specific key. That's a very important distinction. It's easy to screw that up in the beginning when you're learning this. So I'm kind of, repeating myself, but that's how it works. So you want the value that comes out, you have to use the key to access it, just like you would, but in this case, you have a variable to represent the key because it's going to be different on every single loop. All right, let's do an example. We have a new object, Elizabeth. First name Elizabeth, last name Swan. Jewelry is gold medallion. Her likes are Will Turner and breathing. Her dislikes are Captain Barbosa and corsets. Okay, so, and there may or may not be a correlation there, right? So let's use a for in loop just to print these keys and values together in a template literal. Okay. And you have to use bracket notation because that key is a variable. So we'll say for let, and I'm just going to use the variable key to make it really clear what that represents in Elizabeth. Again, you can use whatever you want, but use what makes sense to you. So you remember what that represents. And then I'm just going to create this template literal that just says the key is key and the value is Elizabeth at whatever key we're currently on, which so we'll just use the variable with no quotes. Okay, so this is just a utilitarian, let's just go check our data type of printing. That's all we're doing. All right. All right, there we go. Key, first name, value Elizabeth. Key, last name, value Swan. You see something interesting here. You notice that we had stored arrays, right? As the values for likes and the values for dislikes. These are arrays. And this is an example of where JavaScript does this thing called stringification, where it just turns the array into a string and it just does comma separated values. There's no space, but there's a comma. So that's why it looks like this. Key is likes, value is Will Turner, comma, breathing. Just because it's trying to represent all that stuff from the array. Okay, so that's a good start. We are able to just, loop through each of those pairs and see the key and see the value by using the key to access it relative to the object name. So this is probably the thing that trips students up the most is remembering the difference between these, what this represents and how it is you actually get the value from that. And that's going to be really important when you do your second graded assignment to understand the difference between those two things. Okay. So let's talk about objects that store. Oh yeah, I didn't put how it comes out. Yeah, in this particular case, right, I was just console logging one after the other. So it goes through title, First Fires, artist, Bonobo, album, North Borders. That's what it looks like if it does it in that order. Okay, now let's talk about objects that store other data structures. But this time, the first one I'll do is object storing arrays. And then in a minute, we'll talk about objects that store other objects. Okay. So let's say you have a value that is an array of one of the properties in the object. So you can access that with double notation. You just have to keep track of what type of notation you're using for the object and what type of notation you're using for the array that is the value of that property. So we have movies. The format is DVD. That's just a string. No problem. You know how to do that. Movies.format, right? We also have titles, and the value of titles is an array of a bunch of elements that have, indexing, right? So if I said movie.titles at index 1, what would I expect to see? Oh, hold on. I've got bullet points. Give me just a second. Yeah. So you want to reference the array that uses dot or bracket notation with the property name. And then you reference the element within that array using bracket notation with the index. Okay. So movies.titles at index 1. What am I going to see?
And you said? Tenant.
Yeah, tenant. Okay. So, yeah, we have lots of movies with very short names so that I could fit them on the slide. And yeah, we go first to the reference that gets us to the array by accessing the key here, titles, movie.titles. And then from there, movies.titles represents that array, right? So then we can just use the bracket notation on that array to get to the string tenant. Okay, what about movies at the key titles at index 3?
Speed.
Yeah. Okay, let's do it the other way around. How would I access Dune? Do it with dot notation.
Bracket.
Movies.titles bracket 0.
Yeah, good. What about Avatar using bracket notation for both?
These, bracket, quotes, titles, bracket, index.
So we got movies bracket titles in quotes, and then a new bracket at 2.
Perfect. Yeah, that's the idea. So you're working your way from the outside in. It's just like in multidimensional arrays where you're working your way from the outside in, right? Except for with multidimensional arrays, it's all about indexing because it's arrays of arrays. Now you have an object of an arrays. And so you start with using the right types of notation for the object, and then you go inward and use the index with bracket notation for the specific element in that array. Okay, so that's how you do it with object storing arrays. What about object storing objects? Oh, actually, I have something I want to live code first. Yep, let's do this. Okay. Object storing arrays. Here we go. Okay, so we have Elizabeth's likes and her dislikes, right? Let's go ahead and practice doing a loop here. And we're just going to print these out. Now, the only thing I'm interested in looping through is the arrays that are here at likes and dislikes. So what type of loop do I want to use?
Was that
Why?
a while loop?
No, we have a specific number. I mean, you could, but we have a specific number of elements in each one, and they're the same. So if we know how many times we need to loop, we can just use what?
For loop.
Yeah, just a regular for loop. Yeah, and there's no need for a for in loop. We're not trying to loop through the properties at this point. We already did that up here. We want to go straight to this and loop through this. So I'm going to go to, do a classic for loop. And I can choose either one of the properties, what either one of these arrays because they're the same length. So I'm just going to go to Elizabeth.likes and get the length of that. And we'll just use that as the basis on which to access things from both. So I'm gonna break this out a little bit so that we can use some variables to represent each thing. I'm gonna say let current current meaning the one we're on while we're looping right now. And I'm gonna go to Elizabeth .likes at index I, right? That's her current like. And her current dislike is Elizabeth .dislikes at index I, right? So this will be kind of similar to what you were doing with your questions and answered in graded assignment 1, right? Where you're just doing a single loop, but accessing 2 different arrays. Okay. So I'll say Elizabeth likes, current like. This is why I did it in a variable to make this a little bit easier to read and shorter. All right. So we'll just use whatever's stored in those 2 variables on each loop to place into the template literal and let it print out as it's looping. Let's do it. Okay, Elizabeth likes Will Turner, but she dislikes Captain Barbosa. Elizabeth likes breathing, but she dislikes corsets. Okay. So that's how you can actually, work with data that's stored inside the object just by accessing those particular properties and using what you already know about how to navigate, and iterate through an array, you already know how to do that. You just have to make sure you're getting to the array with that dot notation or bracket notation. You could have done it either way to get to likes and dislikes first. Okay. What about objects? You can have objects storing objects. This is a very common way to store data in the real world. You're going to learn lots more about that when we get to learning about JSON and later with databases and things. Okay, so you can have the value of a property also be an object. So you can use double notation for that too. It's just there's no indexes now. We have no arrays, right? So it's just double dot or bracket notation. So again, you work your way from the outside in. So start with the outer object, find your property name, and then reference the inner object's properties the same way. You just tack it on. You're chaining your references. So I have contact. Name is P. Sherman. Occupation is dentist. Address is an object. Inside that object, I have street is 42 Wallaby Way and city is Sydney. So contact.address.street is going to be what?
42 Wallaby Way.
Yeah. Okay. How would I access Sydney?
Contact.address.city.
Yeah. Yeah. And you can kind of see already, now that we're getting into more complex references, why I like dot notation better than bracket notation. It's a little bit easier to read for this sort of thing. So yeah, you just work your way from the outside in. Okay. Let's do another example of this. Okay, we've got an object for Barbosa. His name is Hector Barbosa. His ship is the Black Pearl. He has a pet. His pet's name is Jack, and he is a capuchin monkey. Okay, print the monkey's name. How would I do that?
Barbosa.pet.name.
Okay. Oops. There we go. Yeah, Jack. There we go. Okay. So let's loop through the pet's keys and print both values. Okay. So again, we're not going to loop through Barbosa's key value pairs. We're going to loop through the pet's pairs. So we have to think that we're still going to use a for in loop. That's what we use with objects. And we're going to try to go through the key value pairs. But in this case, I need to access the pet specifically, right? So I'm going to say let key in and go to barbosa.pet and say that's the object that I want to loop through. And then I'll just print barbosa.pet. And you have to use bracket notation with variables, and key is a variable here, a local variable that represents a different key. So it's going to represent name, and then it's going to represent species, or possibly vice versa, but usually it'll be in the same order it was defined in. There we go, Jack and capuchin monkey. All right. So these are some different ways you can think about how you're going to need to access, things that are nested inside other things. And the more you practice with this, the easier it'll get, and you get to a point where you don't even really have to think about it. You'll just do it. Okay, so one more thing, and I know we haven't taken a break yet, and that's just because I wanted to finish this part of the lecture before we do the math object, but that goes a lot faster. So we're just going to finish this, and then we'll take a break. So this is a little bit of bonus information that's not directly covered in your chapter, but you're going to need it for studio today and also for your graded assignment. So I wanted to go over working with arrays of objects. You can have multiple objects stored in a list. And this is a very typical way that you work with data in the real world, where you have a lot of different objects with different information, but they usually will have the same properties, and you might, be iterating over an array and accessing the same property in every single object. So we're going to do a little bit of that. You take the same approach of working from the outside to the inside with double notation. You're just starting with the array first, right? So you'll reference the array using the index of the object that you want to choose, and then you reference the properties of that object. So I have fruit, which is an array, and it has 3 different types of fruit stored here, an orange, an apple, and a lime. And the orange is the color orange. It's citrus, so that's true. Apple is red and it's not citrus. Lime is green and it is citrus. So different values for each object. And they're stored in a list that we can actually iterate over. So just to test our references, if I go to fruit at index 0 dot color, what do I see?
Orange.
Good. And what about fruit at index 1 dot is citrus? I'm sorry, I just gave away the farm. Okay, let's do this again. Yeah, so that would be false. How about lime? How would I get to that?
What was that? Fruit at index 2 dot type.
Good. Yeah, fruit at index 2 dot type. So start on the outside with the array. So you use bracket notation with an index, work your way inward, and then use either dot or bracket notation with the key in the object. Okay. So I've got an example here. We have 4 objects: Gibbs, Anna Maria, Cotton, and Rigetti. So I'm going to store all of them in an array. So I'm just going to say let Motley Crew equal Gibbs, Anna Maria, Cotton, and Rigetti. Okay, and we have a problem, and I'm not sure what it is. Oh, I somehow missed my bracket when I was typing that in. Okay, there we go. Yeah. Okay, so it's an array. It holds all 4 of these objects, one after the other. You'll notice they all have the same keys, right? Name and position, but then they each hold unique values. All right. So what now that we've done that, we can just print it and see how it looks. And that's a helpful thing. Always print this stuff as you're putting it together, or maybe it's already been put together for you like this, and you're like, yeah, but what does that represent? Log it, just go see what it looks like, right? And then we'll be able to refer to that. So let's run it. And there you go. You can see it's an array of objects, right? You can see every single one represented with each of its keys and values. Whereas when we were creating it, we just used the references to each of those objects. And so it looks like this in our code. So it's helpful to do that. What if we wanted to print the names and positions of all of the members? What would be the easiest way for me to do that right now?
Or loop.
Yeah, we can just loop over Motley Crue, right? Instead of having to go and like manually do it for every single one of these separately. Now that we've put them in an array, it's going to make it easy for us to access each one right after the other with the same line of code. Okay, so I'll just set this Motley Crue.length, increment each time, and now we can just, yeah, access it. Okay, so if I want to do the name, what reference would I put here in order to get to the name of the member in that array?
What was that? Motley Crew dot name.
Okay, so Motley Crue is an array, which means it only has what type of indexing?
I heard a couple things. What was that?
Yeah. First, we need to get to the element in the array, right? So we're going to use I, and then we can say dot name because we're talking about a specific object at that point. This is the thing that's hardest to wrap your head around in the very beginning, is you have to start thinking of this entire thing right here as an expression that evaluates to something before you tack on the dot name. Motley Crue at index I is an object, right? Because it's one of these 4 objects that we stored. And so each time we do this, we're going to represent a different one of those objects. Then we can go inside any one of those objects and access the name. But the very first thing we have to do is get to that object by using, a number index because it's an array. Okay, good. So we can start with the name and say is a, and then we'll do the same thing, Motley Crue at index I dot position. Okay. So we can run this now and see it come out. Yeah, Josh and me Gibbs is a first mate. Anna Maria is a sailor. Cotton is a sailor. Rigetti is a sailor. Okay. So that gets us to there. I think that's all I wanted to cover for objects. When we come back from break, I'll talk about the math object. Does anybody have any quick questions before we move on?
Seeing some thumbs up, I think we're good.
Okay. All right, let's take a 5-minute break. We'll come back and we will talk about the math object. Okay. All right, now we want to talk about the math object. Some different things that exist built in that make math easier for you in JavaScript. So we'll talk about constants, exponents and square root, rounding and truncation, maximum and minimum, and randomization. I'm not going to do a whole lot of live coding on this for the sake of time. I'll just demonstrate some randomization stuff because it'll be useful for you for your studio for today. So constants, there are a few properties stored in the math object. A lot of constants that are commonly used for business applications and mathematical calculations. So pi, if you want more precision than just using 3.14, you can use math.pi. Math.e will give you Euler's number. Math.square root 2 will give you the square root of 2. And a few things like that. So you could, oh yeah, notice the properties. Okay, screaming snake case. I mentioned before that a very common convention for constants like this in JavaScript is to use that, uppercase underscore, also known as screaming snake case. So math.pi, math.e, we can evaluate these. If you were to log these to the console, they're going to come out, looking something like this, where you can have a lot more precision because you have access to those numbers with all of those decimals. Okay, exponents, square root, pretty much as you would expect. You can do double asterisk for exponents and square roots, if you remember that you could do that with fractions. Or you can use math.pow for power and give it x and give it y, the base and the exponent. And then you can do anything with that you would like. And then math.square root, SQRT, just takes whatever number you give it and takes a square root. So instead of 4 to the second power, you can do math.pow, give it 4 as the base, 2 is the power. Same thing, and then of course you get 16. Same thing with this. I can say I want 2 cubed, right? 2 to the third power, and then I get 8. 25 to the 1/2 power is the same thing as saying square root of 25. So we could just say math.square root of 25, and that's a little bit simpler, right? That of course gives us 5. And then same thing with 20, and here you might, you're not going to get a nice number, you're going to get a decimal number, but it will give it to you automatically. What happens if you try to take the square root of a negative number? Anybody know? Can you guess?
You get an
No, JavaScript does not deal in imaginary numbers. So you just get not a number. That stands in for things like imaginary numbers. Yeah. Okay. Rounding and truncation. There are a number of ways to do this. Rounding to a whole number, you can do kind of 4 different ways. One is to use just regular math.round, give it a number, and it will just round to the closest integer. So anything 0.5 and above is it rounds up. Anything below that rounds down. Math.ceil, which you can think of as ceiling, right? That rounds to the next highest integer. Similarly, math.floor rounds to the next lowest integer. And math.trunc, it just removes everything after the decimal point and makes it, it truncates. It just makes it a whole number by virtue of just taking off whatever that remainder was. Math.round would give you, 5.42 is going to round down, so you'd get 5, but 7.8 would round up, so you get 8. So either one can happen. Math.ceil We do 13.2. If you were just using regular round, that would round down to 13, but because you're using seal, it's going to round up to 14 no matter what. Similarly, if you have a negative number like negative 7.7, the next highest number is negative 7. So it would round to that. Math.floor is the opposite. 29.6 is going to round down to 29. Math.floor, negative 31.9 will round down to negative 32. Truncating, again, just takes off the decimals. So 1.489 becomes 1. Negative 94.5 becomes negative 94. Okay. I'm going to give you some examples of when this might be useful. Okay. If you want to round to a specific decimal place, you have to do a little bit of extra work with JavaScript because there's not a way for you to just tell it, oh, and by the way, I want this many decimal places. It would have been nice if they had built that in and given it to you as like an extra optional parameter, but they didn't. So here's how you do it. You just need to do a little multiplication and division. So you're going to create some sort of factor that's just 10 to the power of whatever number of decimal places you want. So if you need 2 decimal places, it's 10 to the 2nd power, which is 100. If you need 4 decimal places, it's 10 to the 4th power, which is 10,000. Another way to think about it is that you want 10 only like with, you just want as many zeros as you want place values, okay? So 10 will give you 1, 10,000 would give you 4 because of the number of zeros. That's really the best way to think about it. And then you are going to multiply the original number by that factor before rounding. Then after it rounds it, you divide it back out. And then it'll give you exactly the number of decimal places that you want. So for 2 decimal places, that factor would be 100. So I would say, I've got some sort of sale price, 23 times, 67%. So I need to round that to pennies, right? That's a practical application. So I'll say math.round, take the sale price times 100. And then after it's rounded, because this entire thing evaluates to the rounded number. Then I subtract out 100. And then I get a total that's 15.41 and no additional place values. And also, it's not a round number. I mean, it's not a whole number, right? If you wanted 1 decimal place, the factor would be 10. Let's say you're averaging temperatures and they're provided to you with 2 decimal places, but you really only want it to be 3. Go ahead and take the average, right? Add them up, divide by 3, fine. But then round it. Math.round would be the average temperature times 10. Do all of that first, then divide the 10 back out, and you get 81.6. Okay. You can play around with that however much you would like, but that is how you do it. You just, however many, your factor just needs to have the number of zeros that you want to have decimal places. Okay, maximum and minimum. This will find the lowest or the highest number in a list of numbers. You wrote a algorithm for this recently, but you can actually use the math object to do it. But there is a catch. So max, finds a maximum, min finds a minimum. Here's the thing. You may notice that these are separate arguments or separate parameters, right? It's not an array. So in order for you to do it, you have to actually extract the numbers from an array. If you have an array of numbers that you would like to find the minimum of, you got to extract it using that spread operator. It's the same thing that I showed you before with pulling out all the key value pairs from an object. It works for arrays too. So you may, if you ever want to try to go use this, just suffice to say, all of these separate values, you're looking at it, in this case, it would be 6 and 1, right? You can see that visually, it's pretty easy to see. Max and min. Let's say you have an array of numbers like this. The only way to give it these numbers is to pull them out of the array with that spread operator and say ... nums. And then it looks at just the numbers inside the array, all the individual elements, as if they were separate arguments that you're passing in. So you can do that, and that'll give you, 53 is the max and 4 is the min. So just tuck that away in case you ever try to do this. Just remember, oh yeah, I can't give it an array. I have to actually extract the elements. Okay, now I want to get to the very last thing, which is randomization, and I'll spend a little more time on this. So the JavaScript math object makes it easy. you can use math.random, and what that does for you is generate a decimal number between 0 and 1, not including 1. So what that means, oh yeah, include 0, does not include 1. It'll be up to 1, but not including it. So you need to multiply math times random by the number you want as that upper bound. If you want a number between, 0 and 10, then you'll have to multiply math.random times 10, for example. And then you can use math.floor and math.ceiling to round it and decide, do you want it to start with 0 or start with 1? So I could either do 0 to 9 if I use math.floor to round it down, or I could do 1 to 10 by using math.ceil to round it up. It just depends on what your need is. Typically, though, I'm sure you can imagine, if you're going to work with indexing on a character or an array of elements, like a string of characters or an array of elements, then you're going to need to round it down, right, to 0, because those are 0 indexed. So here's just what you see when you do this. So math.random, you might get some number like this. It would just be something from 0 to 0.9999999. And then if you multiplied 6 times math.random, it would mean you get something in the range of 0 to 5.99, etc., which would be, it could be anything, but maybe it's just a number like that. So again, if you use math.floor, it'll, on 20, it's going to give you a number from 0 to 19. So I don't know, I would do it and maybe it would end up as 15. But if I round it up with ceil and the same number, 20 times math.random, then it's going to give me a number from 1 to 20. And, it could be 2, it could be 1, it could be 20. You don't know. This has a lot of practical applications. One of the most common and one you're going to need for Studio today is getting a random index for an array. So if you want a random element, you have to remember that, first of all, that math.random only generates that number that's between 0 and up to, but not including 1. So you can multiply it times the length of array, and that's a good starting point because it will at least give you a number, a number that's in the right range. But then you need to make sure to use math.floor to round down because of 0 indexing. So I've got a playlist here, and this is like stuff that my dad loves. So I was inspired by my dad. So 25 or 6 to 4, Sir Duke, Graceland, Hotel California, the music of my childhood. So yeah, so this is my playlist. I've got 4 strings, right? Let's say that I want to get a random index. I may very well have a function that I've created that just goes and gets that for us. Without it being specific to any one array with any specific information. So I can just have that utility function and go stash it somewhere and call it whenever I need it. So I would write something like this: get a random index, pass in the array so that I can get the length, and then just return the length, or you could pass in the length depending on how you want to write this. I would just return the length times math.random, but then that entire thing being rounded down so that it's 0 indexing. And then I have an index I can work with. So if I have a playlist that has a length of 4 and I use get random index and pass in that so that it can use that length, I'm going to get a number back that's between 0 and 3, right? Because we used math.floor. And so I can then go use that to access whatever element is at, that index and playlist, and I have my song. So what if I was to run this and I was to get a random index of 1? What would I see?
Sir Duke.
Yeah, Sir Duke. Okay. So that's the concept. You could have this, done several different ways. So really quickly, I will just come in here and pull this down. All right, I'm going to write that function that's going to choose the random number. We'll do that real quick. So get random num. I'm going to make it, let's do index so that we can be sure that we're going to be rounding it down. If I was to say get random number, you might not know whether that was going to round down or round up or what. So we'll say get random index to make it clear. And I can just say I'm going to pass in, the array so I can get the length. Or, or I could just do it with the length if I wanted to, but I'll do it this way to be consistent. And I will round down the length times math.random, whatever it comes back with, and return that number. So now let me write another function that's going to return a random member of the crew. It's going to be for swabbing the deck. Some unlucky soul is going to get to swab the deck. So get deck swabber, we'll call it. We can say get random deck swabber, and we'll pass in the array. Okay. And so I could say random index is going to be get random index. Oops. Hit random index and pass in the array, right? And then return, and I can go to Motley Crew and use the random index to access that crew member, and I should see the object, one of these 4 objects that's stored in Motley Crew, right? Because we're using that random index to access that object. So let me do that. I'll just log the return value. So I'll say get random index, and actually I was not supposed to do this. I was supposed to say array at random index because I'm trying to make this a little bit more flexible, right? So I'm going to pass in Motley Crew as that array and get that value back. Let's do it. Okay, so Cotton, bless his heart, is the unlucky person who gets to swab the deck this time. Looks like Cotton gets to do it again. Cotton gets to do it again. Why? There we go. Man, Cotton got chose 4 times in a row. Statistics, what do you do? Okay, Anna Maria finally got chosen, and I'm sure she was sassy about it. Okay, so that's it. That's how that works. Any questions? Oops. Anybody have any questions? Yeah, there's lots of resources out there for, looking up all the possible things you can do with the math object. I only showed you a few of them, so feel free to play around with that. All right. So I do have practice on objects. I have quite a bit of practice because you really have to be solid on this stuff for both graded assignments 2 and 3. You're going to need to be really, really solid on a lot of what I talked about today. So feel free to go when you have some of your flexible time, go, pull these up and get a little extra explanation and practice and stuff. And then I have prep stuff for graded assignment 2. I have one called Physician Directory and Catering Menu. Again, these are on Replit, just like a lot of my other stuff because I've had them for a long time. But they will kind of walk you through the process, not just the process of anonymous functions and objects and methods and all these sorts of things and randomness or whatever. It's also going to talk about like, how do you problem solve something? You're told I need to create a program to accomplish this goal. How do you think that through? And that's really what these both do, is try to help you think that through. And it's a really important skill. Okay, so we'll do modules tomorrow. I will also introduce graded assignment 2 after studio tomorrow. And then Wednesday's a work day. You'll be able to work on graded assignment 2, and I'll do a review session after lunch, after check-in, yeah. And then we're going to get into unit testing. You guys have seen unit tests because they're used for auto-grading a lot of your assignments, right? You're going to learn how to write them for yourself. And then Friday, we'll have another work day for graded assignment 2, and that's when you want to shoot for turning it in, just so you can stay on track. For studio today, you're going to select a crew for a space mission. You're going to randomly select the ID numbers and then use that to select the members. And then you'll have another assignment to like perform some mission calculations, like with fuel and oxygen and things like that. Lots of, interesting little ways to practice using objects and also using the math object. All right. And I will leave it to your IAs to give you a few more tips about your approach with this because it's a long one. There's quite a lot going on.